Welcome, everyone. It's the Crypto Lark, and I am very excited to have back on the show Colin Cantrell of Nexus. Colin, welcome back.
Hey, thanks for having me, man.
Absolute pleasure. Now, there's been so much going on over at Nexus, and I was going to do a review of Nexus to just kind of break down what was going on, but I started reading through and I was like, oh man, I got to have Colin on to talk about this because, this so much is happening, so many details of what you guys are developing. It's amazing. You've been very, very busy. Was it 212,315 lines of code? I mean,
Yeah,
Colin, when do you sleep?
when I can. Just got a great team out here too, and so we're all kind of pounding out at it. So yeah, it's been a lot of code, but
That's awesome. And how big is the team now?
we got about a dev team of size, I think 10 or 11 right now. So it's mixed between front end and back end guys. Some of the
Nice.
guys are in office right now, and we got some guys overseas. Jack can maybe come say hi. Jack wants to wheel over here. There he goes.
Hi, Jack.
There we go. Yeah.
Awesome.
And
You're
we
doing good
got
work, man.
Yeah. So Jack's kind of on back end, and then there's the distributed embassies. So there's one in Australia now, which is run by Paul Screen, Nico, and Mike Casey. So they're building a dev team out there.
Nice.
And then so they have kind of Christo in Vietnam and Paul Screen, and then we have our devs here as well, and then a couple guys that are remote. So
That's awesome.
yeah,
That's awesome. It's really good to see
yeah,
the team growing and developing. Now, for anybody who's
yeah.
not familiar with Nexus, I mean, I've done a couple of videos on it, so if you want to check those out, you can, but they're a little bit out of date now because I made my first review on Nexus a while ago, and we've had so many things happening since then. So can you give us kind of the short version? What is Nexus? What are you aiming to do? What is the ethos behind Nexus?
The ethos are kind of as far as we see it, kind of keeping crypto true to its roots and finding ways. I mean, our belief is that the fundamental architecture of a blockchain is what is the limitation. We don't want to go into something like a distributed ledger, which generally let's call like Byzantine fault tolerant, which generally means that you can have two untrusted parties and then they have to agree on a certain truth together. But one of these could be malicious, and that's one of the problems you get with the public network. So I mean, Hyperledger uses that where you have about 30% of the nodes, but we're kind of inheriting some of the positive qualities of the blockchain, but also designing architecture that we believe is going to help make it something that can actually be utilized by the mainstream. So, I mean, we're kind of just keep with those ethos of let's build really great technology and let's build it with community and make it community driven and community run, and finding all these foundational elements and kind of learning from the experimentation that we're seeing with Bitcoin and Ethereum and everything else, and seeing what some of their flaws are, and making sure that, like we were saying earlier, when you're driving a car, it's hard to change the tire. And that's kind
Hmm.
of where we're at with Bitcoin and Ethereum. And when they get really big, it makes it more and more difficult to change that. We're already seeing the challenges Ethereum's having tried to transition to proof of stake because miners aren't willing to give up the amount of ETH that they're earning every single day, which naturally so. I mean, they've invested a lot of money and time into that. So, I mean, fundamentally, we're looking at kind of the base level architectural designs, and we've basically taken some of the good pieces and then also are implemented our own in order to make the technology something capable of kind of more worldwide adoption, which includes and requires, I guess, ease of use.
Hmm.
It needs to be quick to use. I mean, right now, blockchains, they take a really long time to sync. They take a long time to load your wallet. Anybody that knows how to use a code, you got to keep a backup of your wallet.dat files. And there's just all these things that still make it kind of a technically oriented industry, which we want. And then anybody that comes in that's maybe doesn't understand it is just speculating on the price. So we want to kind of maybe bridge that and say, well, bring more people in so that it can be something practically that they're using, right? I mean, 10 years ago, people would say, what am I going to use a smartphone for, or a cell phone? Nobody's ever going to be using, that internet, and like, what, you put a credit card on there? That's crazy. Crazy. Now people complain if they can't put their credit card in their phone on the internet,
That's right.
right? So it's the same type of concept. And I think the people that are really able to do that for people, but make it still fundamental to its roots, are going to be the ones who are going to be successful, because you have to have the decentralization. Like, you can't just do another Ripple or, which is the same problems that we've seen. I mean, because a lot of us crypto guys came in here to say, well, we can actually fundamentally change the entire economic system of the world. At least that's what I remember being in 2013, is we have the capability to do this, and we have the capability to do it peacefully without having to fight anything, by just making systems that are more efficient and work better.
Just moving on and being better and saying, hey, that old system, it just doesn't work anymore. Let's do the new system. And I feel like we get so distracted by that sometimes in the crypto space. Everyone's, let's get rich at all expenses, and there's actually a bigger idea behind it.
Yeah, and keeping true to those roots and then having the technology to back it up, I think, is really important. Why would I want to use this, or why would I want to use that? Well, how do I use this? How do I do that? The technology is pivotal to it. A lot of people say nobody cares about tech, they only care about community, which is true to an extent. You can have an ERC20 token that's worth $1 billion with no tech behind it, right? Because there's a community rally behind it. But for sustainability, you need to have the tech there to bridge the deficiency or the knowledge gap that we have with people, right? Like an iPhone is so advanced, not just in its implementation of all the circuitry and everything like that, but by the simplicity of its use. That's why people have used it. And that's a technology in itself, right? When people can easily use it and easily touch it, it takes a more advanced technology to make that happen, where people just want to push a button. So you make that possible for them. I think that's going to help them look, see, and feel it, and kind of, I guess, deliver to the world, I think, what a blockchain really is meant to do, which just takes looking at all aspects and facets of it, which is kind of a lot of the ground that we cover, from the actual computing technology to even social technology. Well, how do we organize ourselves without CEOs? And then how do we remain efficient, right?
It's a paradigm shift.
Yeah, exactly. And that paradigm shift, I think, is really fundamentally important. And that's something that I guess is one of our core ethos, is making sure that we're moving in that direction, because otherwise we're just going to create the same thing over again, and then we're just going to have to do bells and whistles for it. And I think it's really important for us to be able to have those principles kept alive, in the, I guess, eve of the time that we've been seeing with all the Lambos and the this and the that, like keeping true to that.
I feel like sometimes in crypto, we're just trying to recreate the old system with new landlords at the top, and that's really not what it's all about when it comes down to it. And this is something that's always attracted me to Nexus, because you guys are so technology focused. You're there, you're building, you got your heads down, nose to the grindstone all the time, trying to bring out good tech, and it's a grassroots focus. There's not that let's get out and hype our product continuously and try and, make people just really, really excited for things that aren't really all that exciting when it comes down to it. You're focused on delivering that good tech, and the results have been very interesting. Now, currently, you guys are up to 4,300 transactions per second, and that is really awesome. You can break down exactly what that means, but just to put that in perspective for everyone out in the audience, right now, Visa is doing about like 1,800. Now, they have been stress tested up to about 50,000, but 4,300 blows almost all other blockchains out of the water, except for maybe something like EOS, but, they make sacrifices in terms of decentralization and things like that. So how are you achieving 4,300 transactions per second? How is this possible?
Well, with pre-processing and post-processing, it's kind of the initial architecture. So we'll go into the Tau framework and how that's important. With Tritium, it's the first, and then Amine, and then Obsidian. But with Tritium, it's just a very basic splitting of your pre-processing and post-processing. So the biggest drawback we've seen, or the reason that we have made the 4,300 transactions per second claim, is based on our stress tests of, okay, well, we're running a Brainpool 512 T1 curve, which is 512 elliptic curve, 512-bit elliptic curve cryptography. We want to do verification of the signatures because you need to verify all of that before. That's pre-processing, which should also be doing other basic ledger verification, like am I spending the same next hash, which just basically means, because it's kind of like a private blockchain. Think of your SIG chain as like your own little personal blockchain at Nexus. So you need to make sure that it links up. So that's kind of pre-processing. Okay, well, this piece that's coming in is a part of this piece of this person. It is this person. I'm verifying the signature. And then since our block time is about 50 seconds to a minute, all this pre-processing can be happening in the meantime. And then when the block finally comes in, all of these transactions are already processed, or a lot of that is already processed, so that we can have a single commit on the actual database transaction in order to have that therefore become fully post-processed. So post-processing is, okay, well, there's this smart contract, let's say, for lack of better words. We call them kind of contracts, advanced contracts. We're trying to shift the lingo because I'm not really a big fan of smart devices for various reasons. But essentially what we can do is, so you have this contract script that maybe is executing certain, let's say, changes and registers. Think of registers as little pieces of data. And the post-processing is basically putting it where it is, checking its pre-states, checking its post-states, et cetera, and then committing that to disk. Because a blockchain is kind of like think about it as a verification database system. So they have to pass certain rules in order for that data to actually be submitted, so that you know when you read it from there before that the data was sanitized, it's proper, the ownership was tracked, and that it's therefore immutable when it gets sunk in. So we go to there, which the LLC, or low level crypto, is doing about 4.3 thousand, which is our bottleneck, obviously. And then we have the lower level protocol, which we've stress tested up to 450,000 requests per second, which that's just messaging, which like Amex or Visa or whatever, they're pretty much doing messaging. I haven't seen the internals of this, and they have some verification, like this number. I think they use two numbers in a type of RSA sequence with a private key and a public key, and then your credit card has one of those numbers, and then the bank has another number, and they combine them and make sure that they equal a predicted number or something of the sort. But they're doing some form of verification, but the protocol itself is just passing messages back and forth. So we wanted to make sure that the socket logic was really robust there. So that means you can process that many transactions while you're sending other messages, et cetera. And then the lower level database, which is an embedded database built from scratch in C++, not forked off of anything.
You mean you didn't just want to fork the Bitcoin code like everyone else does?
No, not at all. No. And everybody else, even that didn't fork the Bitcoin code, still uses the same database systems or key types. Namely, a specific key called, let's just call it a prime key, or Kolbit's curve over a 256-bit prime field. That's what Bitcoin, Ethereum, everybody uses that, which creates maybe some precautions that should be observed with the fact that there's a lot of money to be made in cracking those keys. And if there's one thing that's found in a vulnerability on that key, that it affects every single crypto. We use Brainpool, which nobody else uses. So, I mean, if there's a vulnerability found in that, then it only affects us and not everybody else. If there's a vulnerability found in the Bitcoin type keys, then everybody's affected but us. So I think that uniqueness is important. But anyway, I'm kind of getting on a tangent. So they use Level Database, which was developed by Google for an extremely large storage engine. It's very write intensive, but it can handle a decent amount of reads. But the Level Database is what Bitcoin, Ethereum, and everybody else use. We wrote one specifically from scratch, designed for blockchain applications. So that basically the database itself is built for Nexus. And I mean, you can obviously use it for other things, but it's tailored specifically for what we need it for, and what we need it to do. And with it being extremely simple, with basically not adding extra machinery that's not needed, it's very, very fast. I think our tests against Level Database beat it by about a factor of 2. And if there's more optimizations I did to it, which I haven't fully implemented, it would be a factor of 3. If not more, which is when you start adding up large data sets, you start seeing some, how should I say it, some difficulties. Think about it as, if I only have 10 items and I have to search through, let's call them 10 blocks, it's going to take 10 iterations maximum. But that's where you have different types of indexing systems where, okay, well, I can just assume something's in the middle and then maybe search the next middle. And then I don't have to go 10 whole operations. I can maybe do 3. Right? But when you have that from going to 10 becomes a billion or a million, then that gets longer and longer and longer. So I noticed when I was testing benchmarks against Level Database and lower level database, Level Database and Oracle too, which is what your wallet.dat file uses, is BerkeleyDB 4.8.3 MC version. Sorry for it's too specific, but
that's okay. That's okay.
It got slower and slower and slower and slower to the time where actually my whole computer would crash.
Right.
Just trying to do 100,000 writes to Berkeley. Level DB would just decay slower. So this database itself writes order of 1 at the same, all the way across, which order of 1 means it's a constant time despite the data set size, which I think is important when we're dealing with really large data sets. Because one of the biggest bottlenecks, besides just, let's say, I'm doing 1,000 transactions a second, is your data store. Right?
That was going to be my next question, is that long-term data storage, right? I mean, the blocks get bigger, right? And over time, this has been the big conversation in Bitcoin as well. If we get the blocks too big, then mom and pop can't run a node anymore because, so many moms and pops are out there running nodes.
Yeah, they don't. I mean, nobody runs Bitcoin nodes. It's kind of a weak argument, but I mean, mom and pop usually use cell phones, light nodes, but that's been my experience anyway. But yeah, I mean, the data size that's required, over time is a huge problem, right? I mean, I think I wrote it in my last article. I mean, we're talking gigabytes and gigabytes and terabytes a day once we start getting into these really, really large transaction volumes, right? Which creates another bottleneck with your longevity bottleneck. You have the instantaneous bottleneck with 4.3 thousand. With Tritium, we're limiting it to about 650 transactions per second just by limiting the block size to 2 megabytes. Just to make sure that we ease it in, because you don't really want to have a huge data set unless the actual data can be split and shared among other people. So the lower level database, as a foundation right now, it's a local data store, but as it continues to develop through Amin and Obsidian, it's going to become a sharded database where you have a common instance on every node, but you can still access all the data. And then the data can be replicated across all of the nodes so that we can start to share that data, because that's another huge bottleneck that we have with cryptocurrencies. That's why there's the Bitcoin. Well, there's probably other reasons to assume that the block size would be 300 kilobytes. I mean, they want to reduce it.
They want to reduce it on that's right, on BTC, and then on the flip side, and the total opposite side, you have the Satoshi Vision guys saying we want to do 1 terabyte blocks. I mean, that just, you think about that's crazy. You think about that over like a year or 10 years, like how big is that blockchain going to be? Almost no one except for a tiny centralized group of miners will be able to continue to run that.
Yep. And so we have that problem on both sides, which I think there's truth on both sides, and that's why I like to kind of stay out of the whole block size debate and just say, well, you're both right. You're both absolutely correct. We need bigger blocks to scale. That's correct. And we can't scale indefinitely with bigger blocks. That's not going to work, right? Because you have the processing requirement too. And you have to verify all the signatures. I mean, Bitcoin granted caches them sometimes, but you could get other transactions that you don't have, and you have to verify the signatures on all of those inputs. And then the UTXO architecture is another problem too, because I mean, I could send you 5 Nexus and it could require 100 inputs, right? That means that's 100 signatures to verify. That's 100 scripts that need to be processed. And that's 100 vSpent flags that need to be sent in to show, okay, well, these outputs from that they're spending are actually spent too for 5 Nexus. So there's not even equivalence in the total amount that you're sending. And that's another problem. UTXO, I think, was designed to be pseudo-anonymous, where you could have 4 inputs and 4 outputs, and you never know who's who, right? I mean, this could be mine and this could be mine, and you won't know. And that's kind of how Satoshi designed it. That was the idea anyway, which was a novel idea, to start. But now that we're seeing so much zero-knowledge cryptography coming out, I think
technology moves on, right? I mean, back when Satoshi cooked up Bitcoin, we were in a very different technological space. Now, I wanted to ask though, what are your thoughts on pruning, and will pruning be a part of Nexus? Because this has been one idea put forward in terms of how to make that blockchain lighter weight over time.
Yeah, you can prune essentially, and I mean, basically, since the way I described our pre-states and post-states on registers is every transaction has the pre-state of the previous transaction. So a node, in order to verify, only really has to have the most recent state. It doesn't have to carry all of the previous states, which are in the transaction objects themselves, nor really have proof of how it got there, because it just needs one transaction confirmed in the Merkle root of a block in order to verify that that pre-state was verified by all other nodes, because other nodes will verify the pre-state to their current database state and ensure that that's the same. So we'll have kind of a history option. If you want to see the history of every register state change, you can keep local copies of that. But for verification, you don't need to hold all of those. You really only need to know the pre-states or the most recent changes in that specific transaction object. But then again, just because you can, on verification, remove those, does not mean that you can remove them so easily off the disk. Right? And this is the problem. A Bitcoin block is basically it's serialized. So serialized just means you take this computer structure and you change it into a bunch of zeros and ones and dump it onto a disk or dump it over the wire or whatever, right? So it basically, the whole block itself is here. And then you have what's called a block index object that tells you where the block starts so that you can read that. And that's one of the first flaws of Bitcoin, is that you have to read these block index objects into memory, which becomes extremely inefficient. I mean, they have to read at least 400,000, and then that creates memory requirements and et cetera, in order to read that block. And then they have to have a transaction index object in there to read the transaction, right? So if you're pruning a transaction because it's already spent, or an output of that, you're basically taking a little piece out of there, but then that little piece could be 30 bytes, right? Since it's fixed width. And since you have blocks and blocks and blocks appended to that, You can't just say, okay, well, I'm going to make this 50 bytes, because then you're going to overflow on every other block and corrupt the entire database, right? So what are you going to do with that 20 bytes? Well, there's not much you can do. What are you going to replace it? Are you going to put a new object in there? Because those 20 bytes, if you erase it, is just going to be a bunch of zeros. And then you're not freeing any hard drive space at all, are you? Right? So that's another, problem that I'm seeing in consideration of the pruning. I know you can run it in kind of a pruned light mode, which is basically just keeping block headers, which is fine. That's going to be a lot lighter to just have block headers without all of the transaction and all that crap, and you just keep the hashes of them and then you can read them, and that's a little bit lighter. But when you really want to do full sophisticated pruning, what are you going to do with the free space? How are you going to reallocate that free space? Does your database storage engine automatically relocate to those? Our transactions all fixed width, because if they're not the same fixed size, then you're going to just have the luck of the draw if you can actually reuse that space and then reindex another transaction to that space, right? So that's another potential issue, and that's just the way Satoshi did it. We started with Bitcoin code way back when, just to kind of, learn from Satoshi and the way Satoshi thought, in order to see all of the design elements and see the things that were missing to create it. One of the reasons I made unified time was because I saw a comment in the code saying, when NTP is implemented, you remove this from the version message, which network time protocol. And I looked at that, and I'm like, well, this is kind of a centralized time synchronization protocol. Let's make a peer-to-peer one. And that, so I think there was a lot of fundamental qualities that maybe Satoshi was thinking, designing, but never had the time to do, that we kind of looked at and reassessed and then developed. And that's part of, I understand that architecture of Bitcoin, because I've been through that a lot, and I've seen some of the limitations of it, and that's why I changed that in Tritium, where it's pretty much just clean from the ground up code with, basic legacy verification rules in order to just verify the legacy blockchain, but a completely new node and infrastructure. So, pruning can work to an extent, but if you don't basically have an ability to free up that extra space and reallocate it with new transactions, you're still going to have a growing blockchain. I know from the last I looked at the code, you erase a TX index or a block or whatever, the block stays on there. Even if the block's orphaned and not connected to the chain, it's still there. It's never deleted. It's never removed. Those are some potential issues that I'm seeing that may be difficult to overcome with the current implementations in architecture and Bitcoin and Bitcoin-based coins, essentially.
It's really interesting for me, because imagine if Satoshi was to build Bitcoin today, right?
Yeah. What would he do differently?
Exactly, because I'm sure there'd be a lot of things, and it's funny because Satoshi disappeared and went off to do whatever. Maybe he died, get hit by a bus. That would be that would just we assume all this crazy stuff. The guy probably just get hit by a bus, and just stop coming back one day. But the reality is that 2008 was a very different time in terms of where technology was. So what would Bitcoin be like today? And we're all following, the Bitcoin white paper like it's some kind of Bible. And it's like, what have we done?
No,
like, this is technology.
It's outdated in itself.
Yeah,
exactly. Yeah, and that same concept right there, I guess, is another one of our ethos, is what would Satoshi do? Well, let's understand Satoshi to the best of our ability through the areas that we can, read forum posts, kind of understand where he's coming from, and then read the code. And you can understand somebody's personal psychology and the way they think by the way they code. That's how college professors catch people cheating, because people really write unique code. Jack can contest to that. You can't just change variable names. It's everybody writes very unique code, which is kind of a symbol of how they think. So I think
that's true. That's true. That's an interesting perspective on it, actually.
Yeah. So
now, so we've talked a bit about the databases and the pre and the post processing, all that stuff. I want to talk about smart contracts. You guys are working on what you're calling advanced contracts, and so obviously Ethereum is the smart contract player when it comes down to it. Ethereum's had its issues. There's a lot of different smart contract platforms coming in. So what is Nexus's approach to blockchain based contracts, and how would you differentiate yourselves from all the other guys?
So I'd be lying if I said I knew what everybody else was doing, but from a basic understanding of what I know some other people are doing, such as, let's say, EOS, or there's even DAML, contract modeling languages. I think the biggest follow that I've seen is people want to make it generalized. It's kind of like, still mining Bitcoin with a CPU. It's not very fast. Why? Because it needs to handle so many generic processes. Why is Bitcoin mining running with ASICs right now? Because an application-specific integrated circuit is much more efficient. it runs faster because it's doing a specialized process. So that's the first thing that we really do is make it specialized as far as what are useful uses of a contract, right? Like how many escrow contracts do people use in Ethereum? I don't really see too much about that. The most I see is maybe a ERC20 or a ERC 721 token that actually becomes something people say, yeah, this is great. This is a good use case. But all of this other generic processing and capabilities of this Ethereum virtual machine are not used. Why? Because I think that they're looking at the blockchain as a computer, like Ethereum always touted as a universal computer. One is more of a data storage and ownership tracking proofing device to me, and it kind of proves relations between different things, and those relations that are proven are able to create certain actions following that, right? Like I can make a relation proven with my account to say that a relation of this account in accordance with myself is that I can only withdraw it once a week. And then I program that stipulation on there, and then I can't withdraw it. Or I make an allowance account to say the account holder here can only withdraw so much, or the beneficiary, or I can put my money in an irrevocable trust that says this money can never be moved out. And that's a relation I'm giving to that data or a purpose that gives you that functionality that you really want in it, but it makes it specialized, which means it makes it very, very fast. Our post-processing is the contract processing, which our last test was a pretty basic, op register command. I just thought I'm going to fill up some 2 megabyte blocks and see how fast I could process it. And it processed 32,252 transactions in 600 milliseconds, which was a lot of LLD work, right? So obviously the LLD came into a really important point there because post-processing is really relying heavily on the LLD. Pre-processing is relying heavily on the LLC with some LLD requirements too, but a specialization. So that's really important. That's what makes things very quick. And it's also what makes things easy for people. Standard marketing. Why is In-N-Out so great? Well, because they have really good burgers, right? But when I go to In-N-Out Burger, have you ever been to In-N-Out? I'm sure.
I'm not sure if I have or not.
Okay. Well, maybe it's a terrible analogy, but they have
three. Go ahead anyway.
1, 2, and 3. You got a double, you got a cheeseburger, and you got a hamburger. And then they have other sub items and everything, but it's kind of a rule of threes that a lot of people have seen is more than 3 things, people get a little, I'm not saying that we're designing 3 and everything, but it's the concept of it that I'm kind of extrapolating on is that too much and people don't know what to do with it.
Yeah.
Right? And then when we have people that don't know what to do with something, and then they're trying to renovate the world, and then you have the ability for a developer to create security flaws is another problem, right? Giving the developer too much power in a distributed system without the proper training, or in a decentralized way, being able to enforce that type of training, right? How do you make sure that these contracts are up to par and people aren't making massive security flaws? Well, I think qualification is really important, but then again, you have this whole other framework that would have to be created as far as contract reviewing, and then you have other businesses that were the trusted one, and blah, 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 blah. And it just continues on this slow roll. So why not abstract away from developers the ability to make those types of mistakes so that they can just concentrate on developing? Just like we have higher level programming languages or interpreters such as Java or Python, it handles all the memory management and the garbage collection for you. Why? Because using pointers can be a little bit of a pain. We're working on a nice atomic pointer right now because of thread safety. And you get segmentation faults, and it's a little bit of a pain being in C++ because it's a lower level language. It's closer to the hardware. But when you abstract away from that, the developer can just declare a variable and know that it's always going to be available, or all of that collection and handling on the bottom end, they don't have to worry about, which is good because it creates certain levels of developers. And I think there's developers for every layer of abstraction. So, making each, I guess, a layer extracted away from one another so that you abstract it to developers to just be API based. What is most developers? They already know how to use an API. They can use an SDK. They can use a library. They can make an AJAX request. They can make a web form. So why not make it something that's really simple and easy for developers to use? And then you're going to create a more thriving, I think, developer community because you're not going to create such a high learning curve and then propensity for mistakes. But not to limit developers from deciding to go into lower layers. But when you start getting to changing lower layers that have security precautions that need to be taken into account, I think those need to be more formally upgraded and more vetted by other core developers, which means you'd want core developers doing it. I always say, if we send web developers to fix, the IP network, we're not going to have an internet that works very well because they don't understand the lower layers.
Yeah.
You get down on layer 3, layer 2, I mean, it's a completely different world than up on layer 7, on the OSI anyway, which is the application space. So I think it's really important to kind of have those levels of abstraction where there's a strong distinction between each layer so developers can find the layer that they work on. And so then the last one obviously is, scaling, which kind of comes from one of the two. I mean, it really creates a lot of usability and scaling for it. You don't really have to have this specific language or learn this new language or have this learning curve. You can just integrate directly in. It integrates, the API works over web forms or GET requests or anything else. So you can essentially just, have a login page and log into your account on your local service node or somebody else's service node and basically have access to your SIG through a conventional login system that integrates easily. And then embed whatever types of contracts, if it's an exchange or whatever, you can enter into an escrow arbitration or, just click these buttons that do these things. Rather than having such fragmented, overly complex services, because I think Ethereum's biggest mistake was being Turing complete, even though that was their biggest selling point. And I think we're seeing a lot of that coming to the surface.
That's interesting, actually.
Yeah, that's kind of the way we see it. So, yeah, it's then breaking the processing up into multiple layers, and then that's where we get the 3DC stuff and all that. So, that's. If it's not too technical, I apologize.
No, I think it's good. We bring it down at the end, which is the idea that the 3D blockchain and stuff like that. It's so cool because you are seeing things happening at different levels, right? Whereas what we see with Ethereum, everything's kind of happening at the same level, right? Everything's running straight across Ethereum, whereas you're looking at different levels for what can we put here, what can we put here, what can we put here, right? And obviously we've seen the problems with Solidity. Right, and there's a lot of Solidity developers out there, but we have seen these fatal flaws in Solidity that have seen people losing their money, and that's not cool. That's a weakness of blockchain, and we can't have that continuing forward. Ethereum's a multi-billion-dollar beast, but these flaws have come out that have resulted in the fork, for example. And how resistant is Nexus to forking? If there were to be some kind of situation like this, like the DAO, for example.
I think the resistance or the forking issue is less a technological issue because I've thought about it. Well, how do we make it technologically fork resistant? It's more a psychological issue with the community. Is you only get a fork that's supported when the community supports the fork because there is a contention and a lack of consensus, and that's the only way that they have to exhibit their perspective, right? So a lot of the Ethereum drama was the DAO people had their perspective of saving the DAO because they probably were going to lose a lot of money. And, the question is, well, did it violate the consensus rules? Yeah, they made an exception for the consensus rules to overwrite that contract. Is that truly immutable? Is the other side? Well, is ETH really what it was meant to be? And, when the developers decided to just hard fork and do that while there's that contention alive, that's what caused the fragments. Monero, I think when they went to bulletproofs, they had like 5 forks. People are like, we're not going to do this. Or when they changed their algorithm for ASIC, everybody got to have their own fork. And they all just died off. Why? Because there was a strong backing of, hey, Monero doesn't want A6, so we're going to change our proof of work algorithm. And the consensus was there. So when it comes to Nexus, the question is, how well are we able to, convey community opinion or keep community opinion connected? Because when people become disconnected and contentious about what they believe is right, and they're unable to find a common ground, then we get forks or, anything else. That's what created Bitcoin Cash. That's what created Ethereum Classic. All the other cascades were just people following the money. So I couldn't really say like Bitcoin Gold or Bitcoin Platinum or
the Bitcoin Gold. What was the vision behind that? Just, hey, we can make some money.
Yeah, a couple 100,000 Bitcoin Gold pre-mine, and a few other things, and then everybody else just following that. So I think that anything past Bitcoin Cash was more so a symptom of, the Lambo boys. Of, oh,
Yeah.
hey, free money. I'm going to get my free money. I'm going to dump it. There's
Just
going to be a
throwing the
little bit of
name
a
Bitcoin
market.
on there. I mean, you could be Bitcoin
Yeah,
Nexus, right?
yeah. So, yeah, I
Uh,
mean, I think that's a psychological issue that kind of really fundamentally comes down to the governance problem of
hmm.
Bitcoin and Ethereum, and there's still centralized tendencies. And then how do we make this a distributed consensus? I mean, Dash I think has a pretty good model where they have the treasury and people vote, and then it comes out of the treasury and the super blocks and et cetera, et cetera. And then, I think that type of funding mechanism is important. Bitcoin itself not having a funding mechanism is what's allowed Blockstream to be funded by venture capitalists that generally carry their own agenda.
Hmm.
And because of that, then the agenda of Bitcoin being concentrated of all the Bitcoin core developers in Blockstream is kind of Blockstream's agenda, which that's a problem. How do we
How do
see
you
the
keep agendas
difference?
out of it? It's human nature.
Yeah,
We
yeah,
continue
and
to try
that's
to rebuild these structures
exactly,
where somebody can be in control, somebody can be the head honcho, and somebody can take all the
exactly.
benefit from the network, right? That's what we do, and we continue to repeat this process, at least try to in some
Yep,
ways.
yep, yep. And those are part of the failures and the experiments of I've seen with distributed systems is the governance problem. EOS has made an attempt in it, but block producers don't really, they all have to agree on to add more block producers. So how do you get the block producers to change the block producing
It works against
versus
their own incentives, right? You'd have to have
exactly.
20 or a majority of amazingly altruistic selfish miners or selfish block producers in this situation. It goes against their interests, and that's why it's hard to
Exactly.
do a lot of these things. It's the same reason why it's hard to decrease the block reward for Ethereum as an example, just because
Game
it goes
theory.
against the interests of the miners. Right, and even
Exactly.
though
And
there's largely consensus on that, it's still, these ideas are hard to bring through. So, in terms of Nexus, how are you guys looking at longevity? How are you looking at community governance? Are you looking at a Dash sort of
well,
model, for example?
so ours is a little bit different. I mean, right now, the way it works is there's actually three organizations that are independently operated. They have a key that generates a certain revenue, and we do kind of a key evaluation where we go and we have a Zoom meeting and we report what's going on, and then the community kind of raises their opinion of whether they like it or they don't, and we're kind of gentlemen about it, so we always kind of honor that. But as we develop into Obsidian, and this kind of segues that way, it's going to actually be 6 voting groups because I think one of the problems that we have with the governance is that it's either all money based. So, how do the little guys get their opinion? Or miners don't have an opinion; they can only just decide whether or not they augment the version on the block.
Hmm.
Or somebody could be a trader or a staker, or somebody else could just be a regular community member. So how do we balance the opinions of each individual group but have them all together correlate to one greater opinion? And that's kind of where we can talk a little bit more about like the social organizational model, kind of a social architecture that we're developing. Obviously still experimenting with it.
Yeah,
And
yeah.
it's going to
I
take
just
some
one
time.
question quickly before I'd love to jump into that, and you can do
Yeah,
that
yeah.
after this quick question. But like, why 6 groups? Why not 7? Because it was 6 groups, it would seem that you'd run into the potential of often having the situation at a total loggerhead where you might have 3 groups agreeing, 3 groups disagreeing
Yeah.
all the time, not being able to break that tie.
Yeah, well, we did it as kind of a 4 out of 6, so that you basically have 4 of the main consensus-driven voting groups, and then 2 voting groups are more elected voting groups, for lack of a better
Mm-hmm.
words. So you'd have developers and ambassadors, and then the rest of them, so that those would kind of be a swing vote in case like 3 or 2 or whatever of the people, and like if we have miners and stakers completely against, let's say, currency and L1 verifiers, right?
Mm-hmm.
If they're at odds, then the elected officials, quote unquote, can come in and break that tie or swing it one way or another, right? Which helps. But then if everybody doesn't like those officials, then they're able to still get rid of them because it'd be 4 out of 6. So it's kind of, I don't know, it's a mathematical proportion that I think works. That's kind of what we do with arbitration triangles as well. Where if you're an arbiter on a shipment or an escrow, the escrow agent shouldn't actually have possession of the money. They should only be a tiebreaker in case there's a dispute. And if
Mm-hmm.
there's a dispute, you got a deadlock, right? So 3 is the perfect one to sway the deadlock either way. And that's why it's kind of like the third party. So in the same way, that's kind of the reason we chose the number 6 for that specific one, because we think it works really well with that proportion. 4 out of 6 is basically 2 out of 3. And so it creates a consensus based on that. But then if you have, let's say, issues with developers and ambassadors not serving the people's interests, well, how do you get rid of them? Well, all four of the groups can eliminate them as well. So that you still create that ability where there's still a little bit of that balancing, but there's not the complete overruling. So our idea is to kind of make those that, for lack of better words, ascend to higher positions of merit because they're representing more responsibility for the network, which naturally happens. I think one of the problems with decentralization is that we think it's just a completely horizontal flat system, which the idea is that it should be flat in regards to people's abilities or opportunities, but it definitely isn't flat based on people's merit. I know some people that would rather just sit home and surf, or other people that would rather go out and build stuff. And there's just people that have different perspectives and different, I guess, ideas of what they'd like to contribute to a system, or some people that just want to leech, and that's fine. I mean, there's a place for everybody, but I think having your position of the system in balance with what you contribute is very valuable right now. And a top-down hierarchical system, it's really not based on merit, it's based on nepotism and who you really know and who appoints you. So basically, who did you kiss on the political ladder, I guess we should say, to get.
Oh, yeah.
And that's the top-down system, which, you start with the board of directors, the board creates a CEO, and then the CEO appoints their people below them, and then those people create their departments. And I mean, hierarchies are efficient, right? I mean, one person at the top can make a decision, blah, blah, blah. Everybody else has to do it. And then you have aggregation, which is kind of how 3DC works, data aggregation, where 100 people working here don't have to say 100 messages to one person here. They all combine their messages to one person that moves to the next level to carry that message from this level, and then eventually by the time it gets to the CEO or the board, it's highly condensed and something that's very easy to swallow in just a few seconds, which is more efficient, right? So that's one positive aspect of hierarchy. Not to say I condone hierarchy, I'm really actually quite the anti-hierarchist, but if it's a bottom-up system, right, where things are built from the bottom, where you rise to the bottom like oil ascending, but it's the bottom that determines your position, right? Because if you are of a group at the bottom, to be a representative to the group above, you're still a representative here, which means if your base group decides that they don't like you, you can be pulled all the way down. This way, it's the person from the top that decides to evict you from your specific position, which generally is based on only their own personal desires rather than the collective ones. Generally.
Exactly. And we see you can look across most structures that we have right now, and you see the inherent problems of that. It's like I said, nepotism, all these things. We go from a country level where we elect one person to rule the country. Like, why are we doing this? This is crazy. Or one person to rule the company, or one person to rule our whatever it might be.
It's a little bit of a problem.
Yeah.
It's a little outdated.
It really is. It really is.
We've seen it happen over and over again. It's like, we got another dictator. They're enslaving their people. They're killing their people.
Yep.
All right. We got riots in France. Why? Because somebody at the top decided to raise taxes, and now everybody's pissed. And I mean, why with Bitcoin? Well, because Blockstream decided to keep the block size small. So now all of a sudden we got an offshoot, Bitcoin Cash. And then, it's the same story repeated. So I think one of the fundamentals there is the social architecture. Well, maybe if it were a bottom-up social organizational architecture, people would rise based on merit and ability rather than, let's say, taking from somebody or kissing somebody's butt, whatever. I think it's really important for that to happen because there are naturally people with different levels in their evolutionary process, right? That have different capabilities. And to have everybody have a place that's more suited to them, I think is really important. And that also creates levels of data aggregation through each one of these levels. So I can show you some of this is another white paper we've been working on. It's still kind of not really public yet because it's a very experimental technology, but I mean, it has the capability potentially, if it all works, to kind of be something that we can actually use to self-organize ourselves in light of the changing tide of, governments do help us keep from killing each other, right? So how do we
and then they go out and kill people for us,
and
right?
then they go kill people for us, exactly, right?
Yeah.
So how do we keep those benefits where people can feel safe and that there's order in a system, but not constraining freedom and making you a slave, right? And that's something that's really, really important. So that's kind of part
It's
of
about
how.
building the systems of the future when it comes down to it. And
Exactly.
this
Exactly.
is we get so easily lost in crypto sometimes. I'm focused on, oh, we're just getting rich and all this stuff, and there's all these great projects out there that are working to build better ways to, trade energy, for example, or whatever it might be,
Yeah.
or better ways to organize ourselves, because it's we've been so conditioned into the fact that we have to trust our hierarchical leaders, right? These are the people that we have to bow down to them, and it's we've recreated
Yeah.
the systems of the we recreated
Yep.
the monarchy system and said, well, we can now vote for our monarchs, but the results are
Yeah.
still basically the same.
Yep.
Whereas we can
Precisely.
actually evolve our system once again to being the system of
Precisely.
we all can be participants, and it requires
Hmm.
some level of responsibility, and people have been taught
Yep.
that they're not supposed to be
Yep.
responsible for anything. Somebody else is always going to take care of it, but
Yeah.
there can be incentives for being part of that community, being part of that responsibility, and when you have incentives, people will actually come and partake in it. And that's what
Precisely.
we're trying to build with crypto. And that's, I think it's so important to keep a focus on that for everyone out in the community, that yes, we can build a better future, and technology is going to be an important part of that.
Yep. I agree 100%. And social technology, it's about time. I think crypto's kind of lifting the veil over our eyes, saying, okay, well, I think now we're seeing we can revamp the monetary system, which is good. We don't want somebody having a print button.
That's
But,
right. And
what else are we
that's one of
going
the
to do?
first steps. We
Yep.
take
Yep.
control of the money, then we start taking
Yep.
control of the rest of our society.
20 years from now, let's say, I mean, we see this recession continue hitting. Things get worse. We see more riots, like in France. We see currencies completely destroyed in Venezuela. And I mean,
Hmm.
some of those cities having the highest rates of murder. Why? Because it's cartels that take over, in absence of governments, because people don't have the aptitude to protect themselves and the resources or anything else, right? Or that's how mobs come into. That's how dictators always take form,
Hmm.
actually, is when there's chaos. A dictator uses the chaos to say, I will save you all. And then they create a dictator, right? So, I mean, are we going to see this destabilization happening in the world create dictators, or are we going to see that we actually have something we can do with it now? We have technology that we can actually create these sustaining systems from. We can try to do things a little bit differently, and we can look and say, well, these social models we've had for thousands of years, it's millennium pretty much. Like, I mean, all the way back to the oligarchs and tribal leaders. I mean, are we going to change?
The trick's going to be is convincing people that we can move, that there is something new, and that the something new can be better, and it might be
Precisely.
scary, because it is new. People are
Yeah.
scared of new things. I mean, this
Yeah.
is why we keep putting horrible people in positions of power. This is why we keep letting
They're afraid of
dictatorships happen,
change.
because it's what we're used to, it's what we're comfortable with. And the idea of being self-sovereign agents for a lot of people is very difficult. I know for the people listening to this stream, it's not so much. You can think, okay, yeah, I can be a self-sovereign agent, I can take control of my own destiny, but you have to remember that the majority of the population is not where we are. And so it's about
Yeah.
conveying that message to them. And it's, you and me having this conversation, but also everyone out there listening, going out and tell a friend about blockchain, tell a friend about
Yep.
what cryptocurrency can do
Yep.
for the world, right? And that's really important when it comes down to it.
If you feel inspired, take that inspiration and do something with it. I mean, you can do anything that you really choose to do. That's the really beautiful thing about, I think, the time we're going into, is we're coming up to a point where we're getting a blank slate. And what are we going to paint on this empty canvas? Are we going to paint the same thing again, or are we going to paint new stuff? And I mean, just the simple idea that it's possible, I think, was all that I needed. And everybody needs varying degrees. I mean, we're working on the bridges to make it easier to cross. And I think it's important for more people to do that and pick up those torches. And if they feel inspired, to not feel like you can't. Because I think the world is just, I mean, you're told no, I think, 500,000 times by the time you're four, and yes, like, 10,000 times or something.
Think
I
about the
mean,
programming that has, the
yeah,
effect of that
yeah,
is
it just,
crazy.
it affects all of us, where we just think, I mean, I've talked to so many people who say, what inspires you? When I meet community, and I say, well, I want to start my own business. And I'm like, then do it.
Yeah,
They say, oh, well, I don't know if I could do that. That seems, I'm just like, why not? Well,
that's it.
because, blah, blah, blah. And I'm like, so what? Why not? Look at me. I mean, I did what I wanted to do, right? You can do what you want to do too. And they go, you know what? Maybe you might be right. I have this meeting tomorrow and I might be able to get my business kicked off tomorrow. Do it.
Do
And
it.
let me know how it goes. Next day,
Exactly.
got my business started. That's my man. That's how to do it. I mean, just follow it.
Encouragement's so important because
Yeah.
most people, a lot of people, a good portion of people have been defeated by the system already, and it's like this weird matrix thing where you tell them
Yep.
an idea that's outside of the system,
The
they go, no,
matrix.
can't do it, no,
Yeah.
attacked, you're gonna fail, that's not you, that's not who you are, stay at your job, keep your head down, don't say anything, don't speak up, don't try and make a better world, etc., etc., etc. Whereas the
Yeah.
people that we most glorify in society are the ones who have gone against the
Yeah.
system.
Yep. Yep. And I mean, buyers and numerous, the more of us that kind of join together, the more we're going to disassemble the matrix. I mean, if we're not happy being unhappy, then let's make some changes. I mean, it's not going to be easy. I wouldn't lie.
No,
Say
no.
that. But it's definitely worth it. I mean,
The
there's
good
I've
things
seen,
usually aren't easy when it
yeah,
comes down to
exactly.
it.
Exactly. So, I mean, hopefully what we're working on helps, anybody that feels like they want something different. I mean, we hope that we can help on that. And I mean, that's kind of what we're here for, really fundamentally.
Now, Colin, one final question for you for today. So, has your dad sent any nodes into space yet?
No, so they're finishing up. Yeah, they're
Dad, send my nodes into space. What are you doing?
yeah. So there's a couple of areas we got our node built. We're partnered with Space Chain now, kind of working and collaborating with them, creating kind of distributed internet infrastructure. And then Factory's also doing Galactic Sky, which is a software-defined satellite system. So we're
Awesome.
looking into helping do tokenization because I mean you don't want to really go through Swift to verify bank accounts, blah 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 blah. If you're on satellite timeshare, so you have tokens to do that. And that's something we're looking at helping them with. And then our rocket launch is set for March. I think it might be delayed a little bit. We'll have to get a confirmation on that. I think they wanted to give their rockets a little more time to kind of make sure everything was running perfectly instead of deploying them and having them blow up. I think a few other competitors have had some I guess,
That's the
technical
what
issues.
you don't want to happen to your rockets when you
Yeah,
send them
yeah,
up and
yeah. And
blow
that's kind of
up.
what that's ready to do. We figured keep that perspective and make sure that we got everything really solid. So we're still kind of keeping it in beta and keeping it, for the people that really want to be testing it and see the results of it, and then get that deployed. Obviously, over the next few months, most likely. So yeah, we'll see how that evolves. I'll definitely keep once I have an official date. I feel like we've pushed back the rocket launch a few times already, so I don't want to keep
Yeah,
pushing it back.
it'll happen when it happens. Much like
It's
anything, good tech takes time,
everything,
and
everything. Exactly, and that's what's really cool and really important. I mean, seeing this technology evolve. We're talking about building the foundations of new systems here, new communication systems, new, I guess, ways to connect and interact with one another. It's not going to happen overnight, and those that tell you that it will or are claiming that blockchains do millions of transactions a second are most likely full of malarkey, as far as my perspective, to say it in a
it's a nice way
nice
to put
way.
it. Our
So
blockchain will do everything.
yeah. I mean, I see people claiming 2 million now, and I just sit there and go, okay, okay. So
My
that's
blockchain is going to do 1 billion transactions per second.
2 megabytes a second, even if you have 1 kilobyte transaction, which is not possible. So let's just assume it's 256 megabytes a second, which means you're at a gigabyte in 4 seconds.
That's
Sounds
right.
great.
Long-term
Now we're at
sustainability.
86.4 terabytes a day. That's really sustainable.
Yeah,
Really.
that's right. Within a year, it's just going to be filling up data centers quicker than Facebook is.
Yeah, right.
Awesome. Colin, thank
Yeah.
you so much for your time
Thank
today.
you.
For anybody who this resonates with, if you want to be part of the Nexus community, it's a grassroots community. They're developing amazing technology. But some links down below so you can go and reach out to the team on Discord and become part of that community. And it's a great project, Colin. I'm always really excited to talk to you and know what you guys are up to. And
Likewise.
it's Nexus is one of my favorite holdings. So it's I love to see how you guys are developing the technology and how it's moving along. And I really appreciate your time to come and honestly, we just scratched the surface. We just scratched the surface here today. So, and there's a lot of papers, there's a lot of blog posts that have been published recently. So, for anybody who wants to do more of a deep dive on that technology or what's being developed, I'll put some links down below so you can go and check some of that out. But, engage with the community. It's an open community. You can go and ask questions and all those fun stuff. So,
Yep.
Colin, thank you so much for your time today.
Thank you. Yep. Let's do it again sometime.
for sure.